everyone, and thanks for joining us at Emerson's discrete automation booth here. Today is going to discuss how to improve overall equipment effectiveness, otherwise known as improving OEE, including how gaining access to things like new and trapped data can make a huge difference to cost savings and operations, and of course the role that Emerson plays in making that happen. And so I'm delighted to welcome Jan Grasedik, who's right here on my right. He's Business Development Manager for Digital Transformation in the EMEA area. And over here on my left is Stefan Tadje, who is Director of Application Engineering. And they're going to help us gain a more in-depth understanding of what we mean by new and trapped data. That's a term, I'm coming to that in a moment there, Stefan. And of course, the benefits that Emerson can provide within OEE actually going forward. So welcome to both of you, and thanks very much for being here.
Thank you.
Yeah. And Stefan, I am going to start with you. And why don't you give us a bit of background on what we actually mean with this term new and trapped data? I think some people might not understand that. And maybe you could also just give us a few examples.
Yes, I would say to explain that, so we have to start at the floor level. So historically in automation, we had a lot of black and white, in, out, on, off solutions, just as easy. But the demand for more efficient systems demands also more data, of course, more sensing. So sensors are the key. Mm-hmm. That means now what we provide are systems that are more smart, more sufficient. That means we control motion instead of just going back and forth, for example, in a pneumatic drive. So we can control speed, forces, positions, and so on. And this, as I said, demands some sensing. And now with this new data coming out of new sensing, new let's say, feedback from the application. So we are able to control systems, to control motion, to control flow, to control pressure forces in our application. That means that we have a much more efficient system in the begin with, so on the floor level.
So it's essentially data that you didn't see before, that was almost invisible, or that came about because of new machinery and actually new
Exactly.
hardware.
Exactly. The new demands, or the higher demands on the systems. That means the solutions we need to provide. They demand those data. That means they came in addition. There are always some data already existing, and we still use them, like whatever, end positions, for example, like a pressure switch or pressure level. But now in our system, we can use more data and also the historical data to control systems and to gain a much more efficient solution.
So if I understand, obviously we're talking about harvesting critical data, but it's huge amounts of data, as you've said yourself. How does this impact overall effectiveness of equipment?
Now, the more information we have now to run the application, but also to read out the data, to analyze the data, the more we can give back in the OEE or for the OEE, but also for predictive maintenance, for the overall system effectiveness. That means if we have now a position of a cylinder, we can also read out, and now we come to the trap data as well in the background. Yeah. We can read out the speed. We can read out acceleration of the machine. That means we can analyze the all-over effectiveness, the all-over function in the system much better. And the more data we have, we can calculate also like travel speed and so on out of former signals where we just had end positions. So that means we have much more information available, and those information help us to analyze the system.
Okay, so over to you, Jan. Thanks very much for all of that, Stefan, because in terms of things like, for instance, detection of disturbances, this is obviously where OEE tools then come into play. Can you tell us about that?
Yeah, I mean, you have to imagine like a little bit like a clockwork in a machine. Everything is kind of connected to each other there. And for sure, if one of these components now has a negative influence, the overall machine performance goes down. And this is where we can make a difference on, because exactly on this field, as Stefan has mentioned there, with all the products from floor to cloud, we can help our customers to improve this exactly by having additional insights from the products, when they're going to fail, what is the current status, are we good, are we bad with the performance, and how can we help to overcome maybe potential issues in the operational mode they're in.
So it's good that you mentioned the floor to cloud, because I mean, obviously as the guiding vision of that Emerson is following at the moment, but it very much like what we're talking about here, sounds like an incredibly let's say, individualized solution, customized solution for every customer, for each machine. So are you working with any kind of standard, actually, when you're creating these solutions? To what can you tell us about standardization, but also the customized aspect?
I mean, this is one of the most important topics, generally speaking, for the whole industry. Because imagine like you have got different bunch of machines and products on the markets there. And as Stefan has mentioned there, data is trapped. We want to get insights by combining data to kind of one big data source we can leverage in order to get insights. So for that said, we need to leverage standards which are existing on the markets there. And we have got different protocols we are supporting with that. So one of the key protocols we are supporting is like UPC-UA, which we see as an important kind of protocol for the future of the industrial market, but also IO-Link wireless. I could name a bunch of them, but just to name a few of them. And we want to make sure that the products we are delivering to our customers are compatible to these standards there. And ultimately, it's up to us to make systems compatible to the environments there. There will always be kind of a certain, I would call it individualism in the market there, what they're using there. So what we can offer to the customer is like, in that case, we could make a specific solution for the purpose they are looking for in order to overcome their specific pain point and bring additional value to them, finally.
Okay. You got anything to add there, Stefan, to this idea of customization versus standardization?
Yeah, customization especially is coming to my field. So where we are looking really to the application engineering. That means our task is to understand the application of the customer and to find a solution for that. Now, based on the standardization, so we have a lot of functions that are available, but they need to be adapted then to the customer to find the right interfaces, to look for the right data, for example, and also to do the right dashboards, the right output for the machine, for the individual machine. So therefore, it's both. We are depending on a deep standardization, but we have to customize it. We have to make it perfect for the fit in the individual application.
And it's interesting that we're talking about something called discrete automation. I'm just wondering if you could tell us sort of what the specific application focus is for that term.
That's interesting because, of course, in discrete automation, as the name says, we are looking a lot into automation. So this can be a production line. This can be also a process line.
Yeah.
Could be, for example, like steam monitoring or energy efficiency in any kind of process areas. But we're not that picky in this way. So we have marine application, for example, where it's very important as well, to monitor the system efficiency, energy consumption, and so on, to give an overall picture of the effectiveness of the system. That means the technology is, or the need of the technology is very similar in different fields. So, of course, our focus, our background is the automation, but the same needs can be found in a lot of different areas where we can adapt to.
Yeah, and do you have anything to add to that? Because I mean, it seems very open-ended. I mean, it's obviously there is a solution for every possible end situation.
Exactly. So what we try to do is try to put into different, I would call it, focus application. And you can imagine like OEE is one of that. And we give our customers specific examples, like where can we help them with the OEE? So on the one hand, we can do it for our electric linear motion. So for our drives we are having there. We can do it as well for our pneumatics, for the cylinder. So take a look, what is the lifetime of a valve system actually? When do we need to repair these kind of components in the field? And then coming back to your theme like discrete automation, this is the floor level you are starting with. But then there is the next layer above, which is called automation, and the controls which are around that. And Emerson also serves this layer. So we are able to combine the different layers we have in our automation kind of hierarchy in that way, from the floor to the cloud, finally having the software with the insights, making one comprehensive solution and giving kind of one offering ultimately to our customers on this.
And so that's this idea, obviously, of stacked automation. Stefan, back over to you, because you mentioned predictive or preventative maintenance. How is that specifically helping to improve OEE?
Maybe let's give you an example which is far out of industry. Look into a hospital.
A hospital?
In a hospital. Patients are laying on standard stations, and if they don't feel good, they can push the red button or just need to wait that somebody looks for them. If you go for an intensive care unit, you see a control room where you have all the charts, you can monitor all the patients. That means just one person, one specialist, can monitor the status of each one, can see who is stable, who might need some treatment, who needs some extras, and how his situation is developing. It's the same in industry, in applications. That means you have one expert who is able to monitor the whole condition of the machine, and he can see exactly where maybe the stability is changing, where he has to start, changing, doing something to keep the efficiency up.
That's a wonderful analogy with the hospital, because that brings us to the dashboard, doesn't it? And Jan, I'd like to ask you, because the dashboard obviously allows you to have the master overview of all of this incredible data. Can you share some information about how Emerson's dashboard is actually helping to monitor and improve OEE for customers?
Yeah. I mean, you need to know kind of there, in the end, a dashboard should be always based on the demands from the user who kind of ultimately utilize it.
Exactly.
Because it might be that somebody on the shop floor is dealing with it, who's doing maintenance. It might be that the manager wants to see kind of how his factory is running there. So first of all, it's important for us, who is the user of the dashboard. Coming now to kind of what we can offer in this kind of field, it depends also on the scope of the customer. Because one customer might be more into some details because they want to drill down really actually what the issue is now with the machine they're having. They want to see like now, I've got a specific pain point here dealing with maybe the drive into this part of the machine. Some other just maybe want to see this overview, like getting some kind of traffic light system, seeing like, okay, now there is an issue, a red light. Some other might want to see, okay, that they can drill into the details, as I mentioned there. So it depends on the user ultimately. What can we do with dashboards there? And they are in the end just the visualization of the insights we have generated there. Mm-hmm. So it's not that we put the focus on these dashboards. It's more like they are enabling the user to get the benefit out of it, ultimately what we've done before, because we want to analyze the data. And this is where kind of the key knowledge is inside there. And we can then kind of make it just a little bit more smoother and easier for the people to use it.
Okay, so ease of utilization. Stefan, just thinking about the actual, we do a lot of talking about solutions, but it's a bit of a nebulous term, isn't it? What can you tell us about the actual products that are available to help customers improve their OEE?
Mostly, as I said, it's really the sensing.
Okay,
so sensing in the application, whatever you have, gives you the data. What makes you able to analyze whatever's going on in the application or in the process. So that means that effectiveness will be read out by the data, by the analysis of whatever the machine does right now, and gives you the possibility to look for predictive maintenance. For example, to do something right before something happens. And the more data we get, so the more we can analyze. And especially with OEE, I mean, OEE is nothing that is that new. So we have overall equipment efficiency analytics since quite some time, but it's developing all the time. It gets more, it gets deeper. And if you look into systems we have today, where we look for energy efficiency, for example, predictive maintenance, this all gets together. And in the end, I mean, you can even put a price tag on each manufacturing step, where you can see, efficiency has changed. Actually, now this step costs a little more money than before, so it's worth to look into this, for example.
And maybe in addition to what Stefan has said there, like since we are producing this complete portfolio of products there, we are also the experts for it. Meaning like, if we have these trapped data where we just started to talk about initially, we know how to utilize this in order to get the insights and ultimately also to solve the pain points from the customer by that. So this is kind of the unique proposition we can provide to the customer in this kind of case there. And also what is key to success ultimately.
Pain points, that's an interesting term. I like the use of that. It certainly helps us to understand it better. Well, we are sort of getting towards the end of our allotted time. So before we wrap up, I'd like to get some final insights into sort of the overall benefit to customers with this OEE. Jan, perhaps first to you, how can all of this help manufacturers who are faced with things like staff shortages or, for instance, a lack of in-house engineering expertise?
Yeah, I mean, in the end, we have got different topics we are addressing there, and OEE just one which is named there. But you need to know, like, OEE ultimately contains of availability, performance, and quality. And if you have a smooth running process where everything is properly set up, you don't need that much worker, as an example, in the end, to check finally at the end of the production line how good the quality is. Yeah. So by keeping this KPI kind of on a high level, we avoid kind of additional manual work on the products. This is one example how we could do there. Another one would be, for sure, if the performance and availability is higher, you can produce much more in a shorter time. Meaning also you need maybe then kind of less people to support the machine by doing the work ultimately. So in the end, kind of everything is kind of connected within that field. So this is how OEE affects ultimately, I would say, the labor workforce.
Smoothly running machine and such an intricate system. Stefan, how would you sum up how customers can get the most out of these insights and improving OEE, and where do you see things going in the future? Because you mentioned the speed of how things are developing.
Of course, speed is taking off, efficiency is taking off of the application and of the outcome of the production. But I also want to come back to one point what Jan already said. There's really the need of experts. We all know that it's more and more difficult to really have the experts available. With OEE, we can manage that fewer amount of experts can really have an overview about a bigger system and can really go wherever it's necessary.
So staffing efficiency is...
Staffing is a thing, but also do the right thing at the right time. So to really send the right expert to that point that needs to be obtained and not just going there and look and then try to figure out what has to be done. So you can do that up front and you go there and do exactly what's necessary to do, well, to get the best efficiency out of your system.
Well, I'd like to thank both of our panelists for being here today, Jan Grasedik and Stefan Tadje, for educating us on the many ways in which improved OEE can have a positive impact on things like performance and production, sustainability. So thanks again to both of you for being here at the end of such a busy week. And a special thanks, of course, to our audience for your interest and your attention. For further details on improving OEE in your operations, you can visit emerson.com, where you can learn how to implement these improvements and, of course, how Emerson can help you reach your efficiency targets. And with that, all the best until next time from us here in Hanover. Thanks for your interest, and bye-bye for now.